Hi, I'm Adriana Rodriguez. This is Lowell Schudel, Mrs. Crone, and Mr. Grant, and we built the Northern Highlands laser. And here it is.
All right, plugging in.
Vamos.
Plugging in. All right. On. 0. 10.
Light 1.
All right, neon light going. 20. 30. 40. 50. 60. 65. You should see the light go. Beautiful.
Yep.
Go to 70. 80. 90. 100. 110. 120. Gonna hold at 120.
Okay.
Alright. Breathe. In 3, 2, 1.
Outstanding.
You're gonna pull it again, hold on.
3, 2, 1.
4, 3, 2, 1.
Outstanding.
So hello there, this is Lowell Schudel of Northern Highlands Regional High School. We have successfully completed our first test of laser ignition today. Let's show you what we've got. It all starts over here at our wall outlet, beautiful source of power. Goes to our variac, which we will have controlling, regulating safely the amount of power we're putting in. Currently off. Now we have a fuse, a safety indicator light, a switch, and then our transformer. This is a 6x transformer, so we are getting up to 700-800 volts coming out. Here's our diode bridge. We have DC coming off this, or pretty close to DC. Over here we have our trigger, which fires our laser. The string, as you can see, the white string, traces down here, where we have it safely coiled for pulling. The major powerhouse of our laser is this capacitor, a 36 millifarad capacitor, rated for 900 volts. Here we have our resistor bank and a neon light indicating discharge. An inductor, finally, before the laser head. This is a neodymium YAG laser head. It fires in the infrared range at around 1064 nanometers.
Basically, the way it works is we've got a little flash lamp in there, and when the flash lamp goes off, it pumps energy into the solid crystal. It's a solid crystal laser. When it pumps the energy into the solid crystal, the individual atoms, it causes all the electrons to rise to a higher energy level. And when this happens and they go back down, they give off photons. The way a laser works is it's got mirrors on either side, and it's almost 100% reflective on both sides. One side, however, is slightly less reflective. The idea is that by having mirrors on either side in the direction that you want the light to be traveling, the more photons you get going in that direction, when one photon hits an atom, and it will create another photon, and it'll bounce in exactly the same direction. And then it'll hit a mirror and bounce back and hit more atoms, and then hit another mirror and bounce back, and keep going back and forth like that until there's so much light and photons and power build up that it ends up going out the less reflective end. That would be this end, and that is our laser. We'd also like to offer a special thanks to the YSCP program for funding, Sam Goldwasser for being the laser guru, Tony Farrell for helping us with the actual construction of the laser, and our teachers, Mrs. Crone and Mr. Grant, for helping and supporting us through the whole process. We'd also like to give a very special thanks to our camerawoman, Maria Ugarte.
Yay!